Hey, good morning, everyone. So in the 1 hour class today, I would like to continue on one method for finding the solutions in first order differential equations. The method is called the separable equation. So if we look here, it is defined by if we have forms that has dy dx, and then we have a function of x and function of y, just multiply like this. Or if we have complicated functions and we can separate the functions, become two, okay? Function of x and function of y. Then this is what we call the separable. So we could separate the variable x and variable y. And how exactly we are going to process this techniques? Basically, the idea is we are going to separate variable y with variable y and variable x with x. So y with dy, x with dx. And then do the integration for both variables with this time. Okay. So, for example, okay, let me get you into the example. So, or maybe let me start with the. So if you have dy dx, and then you have g of x h y. Okay. Now we are going to take 1 over h of y dy, and then we are moving dx to the right side. And then we are going to take both of them, and we take the integrals. Okay. And you are going to plus constant, and you just need to, maybe it's using one constant, because of course this will have a constant 1, constant 2, but you can just assume that you can plus those two, and you can plus constant here or here, the same thing. And not necessarily to be that important. Okay. And later, if you want to know how much the constant is, it will depend on the initial conditions, and we can set up some initial conditions, okay, to find the constant. Okay. And of course, if you are going to integrate these two expressions, it means that you need some review on techniques in integrations. Okay. In both, I think in calculus 1. Okay, calculus 1. Okay, maybe we can start with this some simple example before I go into a more difficult one. So example. Maybe the question is just solve this. Okay, solve dy dx equal xy. Okay, so first we could take the variable. Let's say we are going to move a y, so become 1 over y dy and then x dx. Okay. And then take the integral. Right? And then what is the integration of 1 over y? Yeah, that's right. This is just normal x, so we just have this x squared over 2, right? So we could take this ln, and don't forget absolute value. Really important. And then x squared over 2. You can plus the constant on the left or right, but usually on the right, okay, just for default writing. But if you plus on the left, still okay, because the constant can be on the left or right. We call this is perhaps the implicit solutions. Sometimes we need to detailing what is y, so we could maybe transform to y. So we need to add the exponent and to become the power, right? So this will be e x squared over 2, and this will also be e to the power of c, right? Now this becomes another constant. Well, to distinguish between the new constant and c, then I think we can make this into another constant d, okay, just to make sure that we, so d e power x squared over 2. And d should be a positive value, right? Because it's e with power of something, so it should be a positive. And sometimes we could check the solutions by just derive and see if it fits with our equations. So if we check, so 2x divided by 2 is x, and then we write this is still d, and then the same e, okay, and this is y, right? So this is xy. Okay. I think at the beginning of the course, I think I mentioned that we are going to see or observe that many solution or equation that will contains the exponent, because the exponent, if you think like the e, it will be very easy to be modeled, and if you derive or integrate, we are going to see more and more e, right? Okay, so let's go for another example. Let me make it here. Another example here. Solve. Oh, I forgot. You can also maybe make this y plus minus because of absolute value. Should be also okay. So sometimes it gives you equations like this, having dy dx. If you can, for somehow, you could make it dy dx equal a function of x and y, it means that it's separable. Or if you can directly separate y, let's say y on the left and x on the right, then you could just do the integration. I think it's very simple. There will be another method to compute, especially for equation like this. So you can imagine this is a coefficient dy and another coefficient dx. There will be another method for this one as well in the future. But let's stick for a separable equation for a while, just to, I think we can review a little bit on calculus. So if you think the calculus is over, it's not, not over. And I think in the other course as well, you're going to use at least some simple techniques from calculus. Okay, if you see from what we have, so let's say we are going to take this. So I will switch like that, and I will make it 1 over y dy and 1 over 1 plus x dx, right? So again, this will be ln, or let me take the integral. This will be ln absolute of y, and this one will be ln y plus x. And then let's naming this a constant, plus a constant. And do the same thing. We can exchange and then make it into e ln y plus x, and then this will be e with power of c, right? And then e with power of ln, that will cancel, so we have 1 plus x, and then e with power of c, and again this e with power of c is another constant, maybe naming with c1, and this will be plus minus e c1 y plus x, or we could make it y equals c 1 plus x. Or we could just make it c because e with power of c is constant, it's plus minus, but we could just make it c, and c can be any numbers. But remember, sometimes when we have our solution, we need to also to check if there's another possibility for others as well. Like the singular solution that we did before, sometimes we need to check. For example, let me get you into another example that sometimes we could have some we call losing a solution. Okay? Okay, let's get through. Let me add. Let me add this. Let's say we have to solve. Y squared minus this is 4. Oh, do you have some extra works for this? Especially for some calculus part and some algebra parts. So you can separate this, become this, right? And then integrate. Okay, and how to integrate? How to integrate this? Anyone still remember? Any idea how? Tangent? Tangent should be plus, right? Any idea? Yes. Correct. Partial fraction. So let me write in another paper here. We could just take the 1 over y squared minus 4, and then this we can factor, right? We can factor becomes y plus 2, y minus 2, right? And then we can write. And basically what we are going to do is finding the constant on both of these two equations, right? Helps to remember how to do it. You can try by your own, but let me just give you the final A and B, okay? You could find it through this partial fractions. And then we could make this into 1 over 4 1 minus 2 plus 1 over 4 y plus 2, and then equal x. This is still equal. We need to take dy, and then let's integrate each of them like that. So this will be a constant 1 over 4, and 1 over y minus 2 becomes just ln, and then y minus 2, right? And this is also similar. Minus, right? Minus. Oh, this is minus, this is minus, this is minus, so this will be minus. Ln y plus 2. Okay. And then we can take x plus, let's just use c1 because I think this will be pretty similar to what we have before, which is we have the ln. That will be later. I think this will get into this e. And then what's next? Maybe just cancel 4 and then multiply 4 here, and this become another constant too. Let's say c1, c2 is 4c1. Okay. Okay, and then ln becomes this. Okay, and then we can remove the ln. So y minus 2, y plus 2 is equal e for x e with power of c2. And then let e with power of c2 becomes just a normal constant. Okay. So it is equaling the c. Okay. If we want to make it into equation explicitly, then we need to solve this. Is correct, right? If you found my mistake, let me know. I haven't checked this yet. Okay, y is 2. And then 1 minus e. Okay, finally. So we can propose this as our solutions. So we can get this as a family of solutions with very of number of c. Okay, so we could have a lot of number of c, right? And then we could think how to check, right? How to check or how to make sure that, okay, this is our solutions. And if we maybe observe, is there any other solutions aside from this? Actually, this type of equations we could predict. How to predict this? So if we take our equations, that is dy dx, and then we say that this is, we get, okay, remember that we did the asymptote before, the autonomous differential equation, okay? Do you remember that? This is, I think, autonomous, right? Because only variable y on the right side. Now, to make it 0, or to make the critical points, we can know that y can be 2 or y can be negative 2. Okay? But if you think from this form, any constant you take, I believe that it will goes through the only positive 2. Okay, so let's go right here. So we could have a critical point that is y equal 2 and y equal negative 2. Okay, So y equal to, of course, this is our let's name it a member of family of solutions. If the c equals 0, okay. But y equal negative 2, y equal negative 2 is a singular solution. Because if you change the constant, no matter what we change in the constant, we cannot get the negative 2. Okay. If you check the negative, it will be a positive, right? Because you have two, right? You have two expressions. So you cannot get any negative. So we could just say that the other solution that we might lose if we just try and make it this is the singular solution, which is the y equal negative 2. Okay? That is one singular solution. Right? That it could be our solution. It could be our solution. Okay? So how to check? Okay? So we need to make this first, so that we can predict, oh, we could have y equal 2 or y negative 2. Okay. So if we did s in the beginning, then we can just make sure that there will be another solution, which is the singular solution y equal negative 2. Okay. So we could write, this is our proposed solution, and if this c equals 0, it will be y equal 2, and the other solution will be y equal negative 2. Okay. Or the question can be completed if it is also includes the initial value or initial condition. Sometimes the questions, they will provide the points, so you could just plug in the points and then you can compute the constant. Okay. So let me just write another example here. Just write the question first. Solve. Now we have the initial value problem. So we have cosine x Okay, that's the question. So we have differential equation, and then we have the initial value. Okay, you could try this first, or if you want to take the notes and make it bigger. And before you did anything, like writing anything after the questions, maybe you could first look the equations and try to separate. You see, I think it's easily defined that we have y here, all y, right? And we have y also here, so we could make this going here, right? And cosine x can be through here, and then we have dx going there. So y and x. Okay, that's the first step. If at the beginning, maybe you cannot separate, perhaps you need to use another method, okay? Which we are going to see later. So the first step, you need to see the patterns, okay? Whether the functions can be separate into x and y, and then you can integrate x, y separately. Okay. Okay, now let's try that function. So we could take this, okay, and then divide by e with power of y, and then dy, okay, for the left side. For the right side, we are going to have sine okay. Oh yeah. Okay, so how to integrate this to okay. So actually you can't really escape from calculus, although you want to. I don't want to see that formula again, but somehow in engineering all will based on the fundamental such as calculus or physics or chemistry. Okay, okay, maybe the right one first. Maybe sine 2x. I think you could simplify this, become 2 sine x cosine x. You can cancel the cosine x, right? So you could just make it sine x, 2 sine x, right? And I think you can integrate it like easily. How about this one? My suggestion is, because it's just e, okay, I think you could take this e to the y and just multiply. You could just pick up here, right? It become negative y, so you could 2y minus y is just e to the y, and the part on the here, let's just write y multiply with e negative y. Okay, and I think we can integrate that. Right? Okay, so this one becomes this, and this one becomes this, right? And this one becomes this. With the sine 2x, remember, you have 2 sine x cosine x. Okay, what's next? I think sine x, no problem here. E to the y, no problem. How about this? This is very simple integration actually, but do you know how to? I think it's a normal substitution, right? Okay. Or no? Or by parts, I think it's also fine. Okay. I think you can do the, or if you are not familiar with the integration by parts, let me give you the, so if you, so let a function, let's say g of y is y e negative y, okay? And the way I'm usually taking this into by parts are by taking, one is to take derivatives and the other one is to integrate, okay? And then writing the functions, and then derive becomes 0, and the integrate become this, and another integration become this, okay? And then add, plus, minus, plus, multiply here, okay? And then finish because it's 0. If you are asking why we doing this di, this is actually the same thing as Okay. But we arrange in a way that we can look at just like at this table. This is positive, negative. But if we have another here, positive, negative, positive, negative, positive, negative, positive, negative. You can see the pattern. So there's one we have positive, negative, positive. And it's the same patterns when we do the normal integration parts like this. Okay? Okay, so we could write that the integration of that. So let me just take integral here. And integration of y e negative y dy is negative y e negative y minus e negative y. And we need to multiply with negative, so this one become e of y plus y e negative y plus e negative y. And then the right side becomes negative 2 cosine x and then plus constant. Okay. I would like to copy again this to the next one. Okay, let me copy to the next one. Okay, so this is actually the problem. So here, okay. Actually, from this expressions, we could make a level curve like you did in the partial derivative. So we could suppose that we could have the g of xy, which is the e to the y plus y e negative y plus e negative y and then plus 2 cosine x. Okay. And we call this a curve, right? Level curves, right? If you remember, we call this function a level curves, which means the functions that is expressed on the right side will determine how high the curve will be. So if you imagine, like the x-y is like the coordinate on the surface, and the value of g will determine the height. So you could imagine like a mountain. So if you reading a map, like your atlas or geography, so if you see, like there will be some contours that are darker and lighter color, it's actually described by this type of functions that which we call the level curve. Okay. So we could define our expressions become level curves, and you see how it goes. We can look here, and this is the level curve with different value of g. With different value of g, we can have this level curve. And actually, what we are going to do is we are going to set which value that is suitable. And of course, we already have the initial conditions, right? So we have initial conditions which we define in the questions, which is 0, 0. So we could just take 0, 0, and then we could get our constant. Okay. So we get the constant. So set 0, 0, right? And then we plug in. So e to the y. It becomes e to the 0, so 1 plus 0, so plus 0 plus another 1 equal negative 2, because cosine 0 is 1, right? And then plus c. So we get that c is actually 4, which means that our IVP solution is e to the y plus y e negative y plus e negative y equal 4 minus 2 cosine x. Or we could also write in terms of a level curves, the c equal 4 means that we have the curve with the value of 4. Okay. And we can also determine through a graph if you would like to see in visuals. So we could take that that is the one that we need in our question. So this is when c equals 4, the level curves. And if you want to check another condition, when you have this point pi over 2, 0, that your c is equal to, okay? Just to describe in the graphics. Okay, I think we only have 5 or 4 minutes left, so I would like to just end here. I haven't give you more exercise, but I think next week we can have 2 more examples. I would like to maybe increase the difficulty a little bit so you could have more idea how to solve this. And we can move to the next method, which is the linear equation. Okay? Linear equation in differential equation. So before we end, I would like you to scan the QR code as usual. Okay, so I will end up until here.